So in this video, we are going to talk about the centers of the triangle. So there's four centers, and they're all created by using different aspects of the triangle. Okay. So today we're going to talk about all of them, and then in some follow-up videos, we'll kind of break it down two and two and do a little more exploration as to what's going on with each of these. So you guys have a little foldable. You can cut along those dotted lines and create that foldable where the four flaps are in the front. So obviously I can't do a foldable on my computer. So I have the flaps on my left-hand side and the inside part on my right-hand side. So we'll deal with that. So we're going to just deal with the fronts for now. Okay. So two of these things we talked about in our last lesson. So perpendicular bisectors and angle bisectors, but they weren't necessarily parts of a triangle. Okay. They can be for sure. And that's why we're talking about it now. But we can also do angle bisectors where it wasn't part of a triangle. So let's start with perpendicular bisectors. For each of these, we're going to draw a triangle. I'm going to do my best to not make it like an isosceles or an equilateral triangle. Okay, I'm just going to kind of do like a scalene triangle here. Okay, forgive my crookedness. Okay, so here's our triangle. A perpendicular bisector, okay, is going to hit one of the sides in a way that bisects it and is perpendicular to that side. So there will be three perpendicular bisectors here. I'm only going to draw one of them, okay? But let's focus on the bottom. The perpendicular bisector, we'll say this is like the halfway point. That's perpendicular. So this right here, this is our perpendicular bisector. Okay. And like I said, there would be two others based on the other two sides. Okay. But perpendicular bisector. And I'm going to make a note that it doesn't need to start from a corner. Okay, some of them will. This one does not. Okay, so our perpendicular bisectors do not necessarily need to start from a corner. Now, based on certain triangles, they might start from a corner, but in this case, they do not have to. Okay, so that was our first one, perpendicular bisector. Let's head over to angle bisector, which we also talked about. We'll do red. So let's draw a triangle. We'll do that again. Okay, an angle bisector, we know it cuts an angle in half. So I'm going to focus on the bottom left over here. So we'll say this is our angle bisector because those two things are congruent. And our angle bisectors can that line right there. Once again, there would be three of them because there's three corners of the triangle. Okay, but there are, this is our angle bisector. And for this one, it does go from the vertex to the opposite side. Okay, and it bisects the corner angle. If that's kind of applied, but I'll throw that in there. Okay, so it bisects the corner. Okay, so now two new words that we have not learned about yet. We have median. Okay, so median, I'll draw another triangle. That was bad. Let me start over. Go like that. So median goes from the vertex of an angle, sorry, vertex of the triangle, so one of the angles, to the midpoint of the opposite side. So it's similar to perpendicular bisector that's bisecting the opposite side. But first of all, it does need to start in the corner. Okay. And it doesn't necessarily have to be perpendicular. Okay. So here, that would be the median because it is starting at the vertex of the triangle and going to the midpoint of the opposite side. So vertex of triangle to the midpoint of the opposite side. And I'm aware that this is a lot of vocab. I'm writing the word vocab instead of something on the opposite side. So this is a lot of vocab. Definitely going to be helpful as we move forward to like have flashcards, do Quizlet until you get this down, because it is important to remember which one goes with which one starts at the corner, which one bisects, which is perpendicular, things like that. And I know that's tough. Okay, so we're going to do some practice with this. And the last one is an altitude. Okay, here's my triangle. An altitude starts at a vertex, goes to the opposite side, and it is a perpendicular to it. So this one is vertex to opposite side, and it is perpendicular to the opposite side. Okay. So 3 of the 4 start at the corner of the triangle. Angle, bisector, median, and altitude all start from the corners. Okay, perpendicular bisector can, but doesn't necessarily have to start from the angle of the triangle. Okay, some of them are perpendicular. Perpendicular bisector and altitudes are both perpendicular. Some of them bisect, so perpendicular bisector and medians both cut that side in half. And then angle bisector is kind of just chilling on its own. It doesn't really necessarily mesh with the others because that's talking about the relationship amongst the angle of the triangle as opposed to what's going on with that opposite side over there. Okay, so those are our 4 features that we are going to deal with. Okay, now we're going to move to the inside and say, well, when we have all 3 of those perpendicular bisectors or all 3 angle bisectors, etc., in the triangle, okay, where they intersect is going to be the point of concurrency, okay, where they intersect, okay, and that is special for each of them, and each of them have a special name, okay, so perpendicular bisectors, we're going to start there again, okay, so first of all, I'm going to highlight in my yellow where all those perpendicular bisectors are. So perpendicular bisectors is what's cutting the side in half and it forming that right angle. So we have XP is a perpendicular bisector. PZ is a perpendicular bisector. And PY is a perpendicular bisector. And if you do not have any highlighters with you, I'm going to ask that you do grab some because we're going to highlight a couple things here. So the first thing we highlighted was the perpendicular bisectors. So I'll do that. Okay, that was that. Okay. The point of concurrency, okay, where they intersect in the special name, in this case, is called circumcenter. And for reasons that we will talk about later, okay, what happens with the circumcenter is if you now look at the distance from the circumcenter to all the corners of the triangles, so AP, BP, and CP, all of those distances are the same. Okay, so we're going to say AP is equal to BP, which is equal to CP. So once again, in yellow, I have highlighted the perpendicular bisectors. They intersect at what we call the circumcenter. But now the cool thing that happens with our circumcenter is if you take the distance from the circumcenter to each of the corners of the triangle, those are all congruent to each other. Okay, and you can also see in the diagram, like our 2 tick marks, our 3 tick marks. So you can also see that the sides are broken down into matching pieces as well. That's just what a bisector is. It's not necessarily part of the circumcenter aspect of things. Okay, but definitely good to know that AP equal to BP, which is equal to CP. Okay, the next one is our angle bisectors. This with red, let me switch colors. Okay, so here are angle bisectors. Once again, I'm going to highlight those in yellow or do whatever color you need to do. So BP is an angle bisector. AP is an angle bisector. And PC is an angle bisector. Okay, it's bisecting each of those angles. Okay, the point of concurrency for this one is called the incenter. The incenter. And now when we have an in-center, actually, I'm going to go back because I meant to highlight. So in the other one, I highlighted all those blue things. I'm just going to reinforce that that is what we got out of that. AP equals BP equals CP. So now in our angle bisector, once you find the in-center, which is where all our angle bisectors intersect each other, okay, if you look at the distance from the in-center to the sides of the triangle, that perpendicular distance, those are all the same. So here we're going to say XP equals ZP equals YP. So that is the cool thing that happens with our angle bisectors. Okay. The next one is medians. So the medians are going from a vertex to the opposite side so that it cuts it in half. So here they're all going to kind of crisscross each other. So AY, we got BZ and XC. Sorry, lost my train of thought there for a second. Okay, so they go like that. They crisscross, they intersect at P. The point of concurrency on this one is called the centroid. Okay. And then this one here, this one is harder to realize. But what happens is if you look at like one of the medians, so looking at AY, okay, the centroid breaks it up into two pieces. So we would have AP and we would have PY. Okay, there's two pieces there. One of them is smaller, one of them is slightly bigger. Okay, the smaller one is going to be a third of the whole thing, and the other side is going to be 2/3 of the whole thing. Okay, or you can also say that AP is double PY. So there's a couple relationships and ways we can write it here. So the way our little flip book wants us to write it is AP is 2/3 of the full AY. BP is 2/3 of the full BC. And CP is 2/3 of the whole CX. But another way we could write it, I think there's a little bit of room at the bottom here. We could also say that AP is double PY. Okay. Or we can say PY is half of AP. Okay, so the smaller one is half of the bigger one when you look at the two pieces that make up the whole thing of the median. And the last one, we have our altitudes. Okay, so that is going from a vertex, the opposite side in a way that is perpendicular to it. So AY is an altitude, BZ is an altitude, CX is an altitude. The point of concurrency on this one is the orthocenter. And nothing really cool happens here. It's just the orthocenter. There's no relationships that get formed. So that's all we are going to write for that one. So once again, I know I just threw a lot of words at you, lots of different scenarios. Okay, we are going to practice trying to figure out which one is which, what we're talking about, what feature it is, what the center is called based on that. So I promise you it's a little overwhelming right now, but you are going to practice and hopefully the vocab starts becoming second nature to you.